Hey students, welcome to the video lecture of recursion. Recursion. Recursion is the process of repeating items in a self-similar way. If a program allows you to call a function inside the same function, then it is called as a recursive call of the function. It means a function is calling itself is known as a recursive function. The process of a function calling itself is known as the recursion. While using recursion, programmers need to be careful to define an exit condition from the function. So exit condition should be carefully defined. Otherwise, it will go to an infinite loop. So the function will call itself again and again and again. It will go indefinitely. So the condition should be written very properly when the recursive call to be end up terminated. Okay, that should be mentioned very clearly. We are going to see how to mention that in the examples. Recursive functions are very useful to solve many mathematical problems such as calculating the factorial of the given number, generating a Fibonacci series, and reversing the string and sum of natural numbers, and etc. Now we are going to discuss an example for the recursive function. Before that, we have to understand how the recursive function is working. Okay, how does the recursion works? Okay, this is a function. Why it recurs is a function name. So recurse, it means a function call. So within the function, a recurse is a function. It don't take any parameter and return type is a void. So within this function, it call itself again. Okay, this is known as a recursive call. A function is calling itself again. So we are having an integer main and recurse here. The first time what will happen, the main function will call the recurse, the function recurse. So after that, what the recurse is doing, the function is calling itself again. So this is known as a recursive call. We will discuss an example for the recursive function. Okay, that is sum of n natural numbers. Okay, sum of n natural numbers. So how to calculate the sum of n natural numbers? Okay, we have to calculate like this. We have to check the physical operation and how to calculate sum of n natural numbers. Okay, just I will open a notepad. I'll tell you what a function will do. If I give a number 5, okay, it's an input. If I give a number, okay, my input is 5. So what will be my output? My output should be, okay, so how to calculate? Calculation equal to 5 plus 4 plus 3 plus 2 plus 1. All from given number up to 1 in a reverse order, we have to add all the numbers and this is the output. So my output is 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1 equal to 15. So we have to perform the calculation in a recursive way. So how to do that? We will first discuss the program. This is a program which is uh, which is created to calculate the sum of n natural numbers using recursive function. Okay, hash include stdio.h, standard input output header file is included. They are responsible for the input and output operation. Here is a function prototype. Function name is sum. Integer is a data type. Integer sum, it will return a integer value and it will take one parameter and the parameter is a integer type. So integer n. Okay, this is a function prototype. In main, in integer main, I'm declaring two variable. One is number and another one is result. Using a printf statement, printf enter a positive number. So it will display in the screen to the user that enter a positive number. The number is stored in the variable number scanf percentage d. Percentage d is the format specified for an integer. We are going to get only one integer. That's why one percentage d is given and the given value is stored in the variable number. So ampersand is address operator. So the address of the memory location, the value entered by the user will get stored. So what I'm doing, the next step, result equal to sum of number. I'm calling a function sum. I'm passing a variable number, and the return value is stored in the result. Okay. So after the statement, what I will do, I will print the result. Sum equal to percentage d result. So sum equal to the string will get printed, and percentage d, the value which you take the format specifier for an integer. Result is integer variable. The result value is get copied in the place of percentage d. Okay, so what is happening now? We have to discuss. So for example, I'm entering a value 5. Okay, so scan of percentage d number is a 5 now. Here I'm calling the function sum of number, sum of 5. Our control directly transfer to the calling function. Okay, number is the actual parameter. Here num is a formal parameter. It will check num equal to 0. Okay, num not equal to 0. It will return num plus sum of num minus 1. For example, if I give a num equal to 5, so in this place what happened? 5 not equal to 0. In this place what it will do? Okay, the num equal to value 5. Okay, equal if 5 return 5 plus sum of num minus 1. So num minus 1 is a 4. So the function is calling itself again. Now the parameter value is 4. What it will do? The function is calling itself again. Okay. So it will do again the value is 5. The function, okay, integer num, okay, 4 will get stored. 4 not equal to 0. Again, it will go to the if part, return num 4 plus sum of num minus 1 equal to 3. The function will call again. Okay. So it will go continuously, it will call until the value is 0. So value is 0, it will return num. Then what it will do? In actually in the innermost function call will return the value to outermost function call. Then after the num, okay, num plus sum of n minus 1 will, the calculation will calculate it. Then the value will return to the outermost function call. So after all the calls are over, in the last call, it will return the value back to the this place. Okay, the value, okay, total value to this place. This is getting stored in the variable result. Okay, we will see the physical operation, how it is calculated. This is my value. I am passing 3. Okay, I'm passing 3 from the main function. I'm passing a 3. Sum of number equal to 3. So sum is a function is called. Okay, now the n value is 3. N not equal to 0. So what will happen? N not equal to 0, it will go to else part. So return 3 plus sum of n minus 1 equal to 2. So the function is calling itself again. So next call, what will happen? 2 not equal to 0. So return 2 plus sum of 2 minus 1, 1. Okay, the function is calling itself again. So if we again, the now the n value is 1. Okay, return 1 plus sum of n minus 1 equal to 0. The function is calling itself again. So in this call, what will happen? Okay, the number value equal to 0. It will go to else part, return n. So the 0 is returned. 0 will come to the next call. Okay, this is 0 here now. Now it will return 1 plus 0, 1 plus 0, 1 is returned. So in this call, 1 is returned. Okay, so here we are having a 2 plus 1. Okay, 2 plus 1, 3 is returned. So here, this is the, okay, up to this, all the recursive calls are over. Here, it will return the value 3. Okay, then actually here we are having a 3. 3 plus 3 equal to 6. When it return the value, it will come and stored in the variable result, and it will get printed. Okay, so in this way, only the recursive function is applied to calculate the natural number. Okay, so this is a program. We will run the program. We will run the program and we will check the result. Okay. First, I'm giving the input which we discussed. I'm giving the value, a positive integer. Okay, the value is 3. Okay, so my output is 6. Sum equal to 6. So how it happened? 3 plus 2 plus 1. So how it is calculated? Okay, each value is calculated by a recursive call. Okay, I will check another test case. So I'm entering a value 5. So my output is 15. How it has happened? 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. Okay. If I give another test case, if I give a 10, the value is 55. How it happened? 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. That is 55. Okay. So that's it for the video lecture. We discussed what is a recursive function and as well as how to calculate the sum of natural numbers using a recursion. Again, I'm telling that, okay, a function which calls itself again is known as a recursive function. The process of calling a function by itself is known as a recursion. So the process is named as recursion. The function is known as a recursive function. Okay, that's it for this video lecture. Thanks for watching it.